Question 4a. Draw the electric field lines of any two opposite unequal charge. Opposite charge means Q1 will be, let's say, positive, Q2 will be negative. Unequal charge means the other charge will have greater magnitude. So let Q1 positive charge and Q2 negative charge, and let Q1 has double magnitude compared to Q2. Actually, it's up to you. Okay, as long as salah satu positif, salah satu negatif, and salah satu has different magnitude. So if I choose to do this positive 2Q1, so how to sketch the electric field lines? So for the positive charge, the electric field lines will go outwards. Okay, so I sketch 10 electric field lines for the positive charge. For negative charge, I sketch 5 electric field lines, just to show that this positive charge has greater magnitude compared to this negative charge. Okay, for question B, find the work done to move a test charge of 5 microcoulomb from a point 40 cm from the point charge of 2 microcoulomb to a point 5 cm from the point charge. So kita ada point charge which is positive 2 microcoulomb, and we want move the test charge positive Q0 5 microcoulomb from 40 cm. So initial dia adalah 40 cm. Let's say this is point A initial to 5 cm, which is at this point. Kita label sebagai point B. So based on the question, kita ada point charge Q, test charge Q0, and we move this test charge from 40 cm to 5 cm. What is the work done? So work done, we move the test charge from A to B, initial to final, equal to Q0 times with potential difference. So the potential difference will be from final to initial, VBA. So Q0 VB minus VA. Q0 is 5 microcoulomb. Meanwhile, VB you can get from this equation, KQ over R minus VA, KQ over R. Substitute the value. Make sure you know which one is initial, which one is final. Then you will get the answer for work done from point A to point B equal to positive 1.575 joule. It's positive, thus work is done by the external force. So let's check, betul ke work is done by external force? Okay, now we have positive test charge and also positive point charge. Sepatutnya dia repel, but we bring this test charge nearer to this point charge. So susah untuk bawa daripada point A to point B. Thus we need external force to bring or to move this test charge to point B. Question number 5. There are 3 point charge, negative 1 microcoulomb, positive 2 microcoulomb, and positive 3 microcoulomb are fixed along a straight line as shown in the figure. Calculate the resultant force on point charge at X, point charge at Y, and also point charge at Z. We want to find the resultant force. For question A, we have negative, positive, and positive. So we want to find the resultant force on charge X. First, label the direction of force exerted on this X charge. Negative and positive, it will attract. So force exerted on charge X due to charge Y. Negative and positive also will attract. So this is the direction of force on charge X due to charge Z. Okay, to find the resultant force on charge X equal to F on charge X due to charge Y plus with F on charge X due to charge Z. So sebenarnya dia sama je dengan Q1, Q2, Q3, tapi dia pakai simbol X, Y, Z. So it's actually the same thing. Okay, so F, X, Y equal to, K Qx Qy over R square plus with K Qx Qz over R square. So make sure you know what is the value for R. So for question A, we will get the answer 55.8 Newton and the direction will be to the right. For question B, we have negative, positive and positive. The resultant force on charge Y, so force on charge Y due to charge X will be to the left, and force on charge Y due to charge Z will be to the left also, sebab dia repel. Thus, summation force on charge Y will be equal to force on charge Y due to charge X plus with force on charge Y due to charge Z. Since both of these force move to the left, so we put the negative sign right here. Then, substitute the value, you will get the answer negative 105 Newton, and negative shows that the resultant direction will be to the left. For question C, do the same thing. Find the resultant force on point charge at Z. Label the direction of force exerted on charge Z. Then Z and X attracted, it will move to the left, F, Z, X. And positive repel, so F, Z, Y. So for this one, you kena tolakkan lah yang besar tolak yang kecil ataupun tambahkan semua. Summation F on Z axis equal to F, Z, Y is positive because it's moved to the right, plus with negative F, Z, X. Okay, so substitute the value, then you will get the answer is positive 49.2 Newton. Thus, the resultant direction will move to the right. For question 6, calculate the electric potential at point 10 meter from a point charge 5 coulomb. We have a point charge Q 5 coulomb and kita ada point A kat sini contohnya at a distance of 10 meter. What is the electric potential if we want to move a test charge from infinity to this point A? Thus, we can find by using this equation, V equal to KQ over R. Then substitute K, 9 times 10 to the power of 9, Q is 5, R is 10 meter. Then you will get the answer as 4.5 times 10 to the power of 9 volt. For question 7, determine the electric potential at point A due to the two charge Q1 and also Q2. Since there are 2 point charge, we need to find the resultant electric potential. V at point A equal to V at point A due to charge Q1 plus with V at point A due to charge Q2. So VA1 is equal to KQ1 over R plus with VA2 is KQ2 over R. So Q1 is positive, masukkan positive. Q2 is negative, substitute the negative sign into this equation. Then you will get the answer 1.5 times 10 to the power of 8 volt. This is the electric potential at point A due to the two charge. For question 8, calculate the electric potential at point A for the rectangular grouping of charge as shown in the figure at right. So actually sebenarnya dia nampak macam bentuk rectangular kat sini. So there are 3 point charge, and what is the resultant electric potential at point A? We want to find V at point A. So V at point A is equal to V electric potential at point A due to charge Q1. Let's say this is Q1, Q2, Q3. Plus with V electric potential at point A due to charge 2 plus with electric potential at point A due to charge 3. Okay, so tambahkan sahaja semua and put the negative sign if the charge is negative. So KQ1 over R plus KQ2 over R plus with KQ3 over R. So substitute the value and then you will get your answer as 4.24 times 10 to the power of 5 volt. Question number 9. If Q equal to 1 times 10 to the power of negative 7 coulomb, calculate A, the electric potential at point A and point D, which is halfway between B, C. Okay, right here in this diagram, we have point A, point B, and point C. At point B, there is charge, which is Q. So it's positive. Meanwhile, at point C, there is also charge, which is positive, and 2Q. So Q ni is 1 times 10 to the power of negative 7. Untuk point C, dekat point C ada charge positive, which is 2Q. 2 times 1 times 10 to the power of negative 7. Find the electric potential at point A and point D, which is halfway between B, C. So first, find VA at this point. Second, find VD at this point. Let's start with A. So A is at this point. There is 2 point charge, Q and also Q, 2Q. So the electric potential at point A equal to VA due to Q1. Let's say this is Q1 and this is Q2. Plus VA on the second charge. So just substitute the value. So K is 9 times 10 to the power of 9. Q is 1 times 10 to the power of negative 7. Divide with R. So R between point A and point B is 10 centimeter. Plus with K is 9 times 10 to the power of 9. 2Q it is 2 times 10 to the power of negative 7. Divide with the distance between point A and point C. 10 times 10 to the power of negative 2. You will get 2.7 times 10 to the power of 4 volt. This is the electric potential at point A due to the 2-point charge at point B and point C. Then to find the electric potential at point D due to these 2 charge. So the electric potential at point D is equal to electric potential at point D due to the first charge plus with the electric potential at point D due to the second charge. So KQ over R plus KQ over R. So K is 9 times 10 to the power of 9. The first charge is 1 times 10 to the power of negative 7. Divide with R. So what is R? R is the distance between point B and also point D. So it will be 0.05 meter plus with K 9 times 10 to the power of 9. Q for the second one is 2 times 10 to the power of negative 7. Divide with the distance between point D and point C. Also 0.05 meter. Then you will get the answer 5.4 times 10 to the power of 4 volt. This is the electric potential at point D due to the 2-point charge at point B and point C. Question 10. Figure shows 2 parallel plates separated 0.5 cm. Okay, the distance between these 2 plates is D equal to 0.5 cm. Connected to the terminals of a 100 volt battery. This is delta V, the potential difference of the battery, 100 volt. Proton and electron are each released from the positive plates and the negative plates respectively and experience electric force. Both move in the opposite direction. So we know this one will be the positive plates and this one will be the negative plates. Calculate A, the electric field strength between the plates. So since we have the uniform electric field strength between the 2 plates, we can use this equation. E equal to delta V over D. Delta V is 100. D is 0.5 centimeter So the electric field strength between the two plates 2 times 10 to the power of 4 Newton per Coulomb. For question B, find the electric force exerted on proton and electron. We can't use this equation, okay, Q1, Q2 over R squared, because we don't have the point charge and we don't have the R between them. So cannot use this equation. Thus, we can use F equal to Q naught E. Why? Because we have the uniform electric field strength between the two plates. And Q naught will represent the test charge, either proton or electron. So if the test charge is proton, then F equal to Q naught E. Q naught is 1.6 times 10 to the power of negative 19. This is the fundamental value for proton and also electron. Times with the electric field strength between the two plates, 2 times 10 to the power of 4. Then we will get 3.2 times 10 to the power of negative 15 Newton. If the test charge is electron, use the same equation, Q naught E, and the magnitude for electron is also the same, which is 1.6 times 10 to the power of negative 19. Bezanya yang ni positif, yang ni negative tu saja. 2 times 10 to the power of 4. Then we will get the same magnitude, which is 3.2 times 10 to the power of negative 15 Newton. Yang membezakannya adalah arah dia. Proton will move to the right, electron will move to the left, depends on the attract to which plates. For question C, find the speed of the proton and electron. So we need to apply the equation of speed or velocity that we have learned before. Why don't we try V equal to U plus AT? So can we use this equation? We don't have the time taken, so we cannot use this equation. Let's try V square equal to U square plus 2AS. Right, so V square is what we are looking for. U square, initial velocity. Since the question mentioned are each released, this shows that the electron and proton are released from rest, from the positive and negative plates, and then they move up to attract to the other plates. So initial velocity will equal to 0. Acceleration, how do we get the acceleration? So we can use acceleration equal to Q naught E over M. S is the distance when the proton and electron release. Maksudnya dia akan datang daripada hujung plates, dia akan pergi sampai attract to another plate. So it will be displacement equal to the distance between the two plates, 0.5 cm. So for proton, V square equal to U square plus 2AS. Initial velocity is 0. Thus, V square equal to 2. A is Q naught E over M and S. Substitute the value. So, square saya bawa ke kanan. It will be set. 2. Q naught is 1.6 times 10 to the power of negative 19. E is the electric field strength between the two plates. 2 times 10 to the power of 4. Divide with the mass for the proton, which is 1.67 times 10 to the power of negative 27. Time with the displacement, 0.5 cm. For the speed of proton, you will get 1.38 times 10 to the power of negative 27 meter per second. After this, try to do for electron. Yang membezakan dia adalah the mass of the electron. Mass electron yang ini. Okay, substitute into this equation. Then, velocity untuk electron, you will get 5.93 times 10 to the power of 6 meter per second. For question 11, what are the differences between conductors and insulators? These are the suggestion answer. For conductors, it is the materials that allow electrons to move freely through the materials. Electrons are loosely bound or free electrons. Conductors allow charge transfer through the free movement of electron, and most metals are good conductors. Meanwhile, for the insulators, it is the materials that prevent the free flow of electrons. Electron can be transferred to or from the surface of insulators, but it is by rubbing or applying heat through friction. While insulators are not useful for transferring charge, they often mount upon insulating objects to prevent charge from being transferred from the conductive object to its surrounding. And then you can list the 5 conductors and 5 insulators of electricity. You can also include the other materials maybe you found from the internet, then you can just put it as your answer. Question 12. Explain an instrument or any experiment that can be used to detect the presence of electric charge of an object. First experiment, we can use gold leaf electroscope. Okay, you can find the explanation based on this link, or you can search what is gold leaf electroscope, and then we also have Van de Graaff generator or electroscope. So try to figure out what are these instruments and what experiment can we do with this instrument. Question 13, explain a real life example of electrostatic. So this one you can put any examples that you know or maybe you found from the internet and list it out. Okay, kalau you nak explain much more details, yes, you can also explain what will happen to the charge, when does the charge transferred from an object to another, and then how does the charge will make electrostatic occur. 13b, how can we reduce the effect of static electricity without shocking ourselves? So these are the example of the answer. First, we can ground our body. Okay, so this is the explanation. You can search on the internet. Second one, wear low static fabrics and shoes. So these are the example of the answer. For question C, give an example of any technological invention that related to electrostatic. So to prevent electrostatic, so maybe we can use ESD or anti-static safety shoes. Second, anti-static carpet tile, or ESD rubber sheet and tile flooring, or we use lightning conductor. So ada macam-macam lagi sebenarnya, but these are the example, and to explain the example, then you can refer to this link. Okay, ataupun you can find from the other link in the internet.